Hello guys, welcome to my YouTube channel. In the previous video we will discuss about normal distribution. In this video we will discuss about fourth concept of unit 2, that is uniform distribution. To solve the problem of uniform distributions, we have to know about the two methods. The first method is probability density function, that is denoted by small f of x equals to function 1 by b minus a for a less than x less than b and 0 for else or otherwise. The second method is cumulative density function, that is indicated by or denoted by capital F of x equals to function 0 for x less than or equals to a, x minus a by b minus a for a less than b minus a less than x less than b, and 1 for x greater than or equals to b. The important key points to solve every problem of uniform distribution, that is, the first point is in probability density function or in cumulative density function, if given value is in mod type, that is like this mod type, we have to change it in as a less than x less than b format. That is, here for example mod x less than 2 gives rise to, you have the minus 2 less than x less than 2, which is in the form of this one, that is a less than x less than b. Here we take a, b values as minus 2 or plus 2, because here mod x means plus or minus x values, that is here x mod x value is less than 2, so that's why we taking 2 as minus 2 and plus 2. The second point is in cumulative density function, if function is greater than type, change it into less than type. That is, here given that p of x greater than 1, it is in the form of greater than type, greater than or greater type, so we are changing it into less than type by minusing from 1, that is 1 minus p of x less than 1. The third key point is in cumulative density function capital F of x equals to formula is x minus a by b minus a. Here x value is substituted in place of which is given here x value, that value only substituted here in x place, and here a, b value will be substituted in the given condition value, which is this condition values we will substitute here, that is a, b values. The fourth one is to convert probability density function to cumulative density function, we use integrations, and for cumulative density function to probability density function we uses d by dx, that is derivation method. Here mean, to find the value of mean for the problem we use the mu equals to a plus b by 2 formula, and for variance value we uses the formula sigma square equals to b minus a whole square by 2, whereas standard deviation is square root of this variance value, that is like this. By using this all key points and formulas, we can solve every problem related to uniform distribution concept. Let us consider an example problem. Here question given that a random variable x has probability density function, that is small f of x equals to function 1 by 4 for mod x less than 2 and 0 for else. Here we have to find the probability of x less than 1 and probability of mod x less than 1, and third one is probability of 2x plus 3 greater than 5. Let us start the problem. Here we know that small f of x is for probability density function, small f of x is the formula that 1 by b minus a for a less than x less than b and 0 for else. Comparing to this function and this function, will replace this f of x equals to, here in this place we have 1 by 4 and it is in mod type. We know that the key point, if in a question that is mod type function, we have to change it in the form of a less than x less than b, that is here mod x means plus or minus value, here value is 2, that is mod x equals to plus or minus 2. So here the bigger value taken as b and smaller value taken as b, here Plus or minus means minus 2 less than x less than 2. That is, we write in this place. In this place we write minus 2 less than x less than 2 and 0 for else. And this also we came done by using this condition only. Here b value is 2 and a value is minus 2. Substituting in this place 1 by b means 2 minus a means minus 2. We get what value? 1 by 2 minus into minus plus 2. We get 1 by 4. 1 by 4 in this value. This also depend upon this condition only. And here this one we have to find. First one is p of x less than 1. That is integration minus infinity to infinity f of x dx is, we know that the key point for probability density function. Here given value is x less than 1. That is, we have to start from 1 and less than x. That means in the place of minus infinity we have to substitute the value is minus 2, because we have the condition in between minus 2 to plus 2. So here we are asking only for less than 1. So here less than 1 means we came minus infinity. In place of minus infinity we get up to what have we starting? Minus 2. That way the starting value we take minus 2, and in the place of infinity we take this value 1. Here f of x plus we get the function is 1 by 4 dx. Here taking outside 1 by 4 and minus 2 to 1. Here nothing how means we write 1 dx. Here 1 by 4. The formula integration of constant dx means minus integration of minus infinity to infinity constant dx means we have formula is x. So in place of this we substitute this formula, that is x minus 2 to 1. We get 1 by 4. Substituting 1, replacing 1 value for 1 time and replacing minus 2 value 1 time, we get 1 minus of minus 2. We get 1 by 4, 1 plus 2 and use raised to 1 plus 2 3 by 4. This is using the method 1 formula, that is PDF method, using method 1. Second one we have to know about, find out the p of mod x less than 1. That is, we know that in the key point, if the here have mod type, we have to change this into a less than x less than b form. So here mod x means plus or minus x value. That is, here given value is 1. That is mod x equals to plus or minus 1. We take in this type, we take minus 1 less than x less than 1. This one changes into this type, that is like this. Here we take integration minus 1 to 1, because it is the condition from minus 1 to 1. So that we taking integration minus 1 to 1 f of x dx. In place of integration minus 1 to 1 f of x plus we take 1 by 4 dx. Taking 1 by 4 outside, 1 dx formula is x minus 1 to 1, we get 1 by 4, 1 minus into minus 1, we get 1 plus 1 2 by 4, that is 2 1 2 2, that is 1 by 2 value. Now we have to find the third one, that is p of 2x plus 3 greater than 5. Changes it into as p of 2x greater than 5. It is here plus type. We are transferring it to left side, it will be minus 3. That we get 2x greater than 2. Here 2x is into 2 into x is there. Substituting there, it will be by 2 this one. That is 2 by 2. 2 ones 2 ones, we get p of x greater than 1. In the key point we will learn that here p p of greater than 1 means we know that here minus infinity to infinity f of x dx. Here the value is starting from 1. Here value x value is greater than 1. So here in the place of minus infinity we get 1 value, and it is x is greater than 1. That means in the condition here we have minus 2 to 2 plus 2 value. So greater than 2 means this value we will take. That is in the place of infinity we take 2 value. F of x function means we take 1 by 4 dx. Taking 1 by 4 outside, and 1 dx formula is x 1 to 2. We get 1 by 4 2 minus 1, that is 1 by 4. We get the value is 1 by 4. This is using first method, that is probability density function. Now we have to use the second method, that is cumulative density function for all these questions. Let us do that method for all this. Using second method, that is cumulative density function for first problem, that is p of x less than 1. Here in this place we write the formula is f of x equals to x minus a by b minus a. In the place of x we place the value is 1. Here x less than 1 only na, so in the place of f of x we take f of 1. In place of x we take 1. This a b values are taken from this condition. We know that the condition in minus 2 x less than b, that is a b value taken from this. That is in place of a we take minus 2, in place of b we take plus 2, minus of minus 2. That is 1 minus into minus plus 2 by 2 minus into minus plus 2. We get 3 by 4 for p of x less than 1 by using second method, that is cumulative density function. Coming to the second one, that is p of mod x less than 1. If it is in mod type we have to change in the form of a less than x less than b na. So it will be changed as minus 1 less than x less than 1. Take it as c and take it as d. We have the formula for this type of questions, that is f of d minus f of a. This is f of c. This is the formula. In place of d we take the value is 1, and in place of c we take the value is minus 1. This one we know the formula is x minus a by b minus a, and same here x minus a by b minus a. In the place of x we have to substitute the value 1, and this a b values are taken from the condition, that is minus 2 less than x less than 2, which is given in the function. So here a plus we take minus 2 and b plus take plus 2, minus of minus 2. Same here also, in place of x we take minus 1, minus of minus 2 by 2 minus minus 2. We get 1 plus 2 by 2 plus 2 minus 1 plus 2 by 2 plus 2. We get the value is 3 by 4 minus 1 by 4. We get 3 minus 1 2 by 4, that is 2 ones 2 twos 1 by 2. For the third one, that is p of 2x plus 3 greater than 5. We only do that this value came as x greater than 1. When in the CDF, in the key point we learned that in the second method only, if there are greater than we have to change it into 1 in the less than type, that is 1 minus p of x less than 1. 1 minus p of x less than means f of x. Formula is x minus a by b minus a. In the place of x we substitute 1. A b values are taken from this condition, minus 2 less than x less than 2, that is minus of minus 2 by 2 minus of minus 2. We get 1 minus of 1 plus 2 by 2 plus 2. We get 1 minus 3 by 4, that is we get 4 ones minus 3, that means 1 by 4. We get the value is 1 by 4. Thus for this third problem. So here the value of p of less than 1 and the value of p of mod x less than 1, the value of p of 2x plus 3 greater than 5, all are same like the value came for the method PDF. You can see that here 3 by 4, 1 by 2 and 1 by 4. Here also in second method also we get 3 by 4, 1 by 2 and 1 by 4. For the uniform distribution function we can use any one of the method. If we do that we get same answers for same method, two method only. So we can use any one of the method in the exam point of view. Let us consider the second question. Question given is, if x is a random variable using point 1 comma minus 1, you have to find the probability density function, cumulative density function, mean and variance. Let us start the problem. We know that PDF is given by small f of x equals to 1 by function 1 by b minus a for a less than x less than b and 0 for else. So PDF equals to small f of x. Here the point is given 1 comma minus 1. This point will be substituted in this AB place, that is taken bigger value as b and smaller value as a. Substituting in this 1 by b means 1 and minus a means minus 1. In place of AB value minus 1 less than x less than 1, 0 for else. We get PDF f of x equals to 1 by 2 minus 1 less than x less than 1, 0 for else. This is a probability density function we get. The second one is we have to find the cumulative density function, which is indicated by capital F of x and function is 0 for x less than or equals to a, x minus a by b minus a for a less than x less than b and 1 for x greater than or equals to b. Here the cumulative function is 0 for x less than or equals to minus 1, because here point given is 1 minus 1. We are taking a value as minus 1 and b value as 1. So here we get x less than or equals to, in a place we substitute minus 1 and in x plus. Here second one CDF means we have to find CDF. To find PDF to CDF value we have to use the integration. That means here CDF values we know the PDF value. In the key point we know that to convert PDF to CDF we use integration. So here we have to find a CDF value. We know already PDF value. For finding CDF value use integration. One integration of PDF, that is PDF value is 1 by 2 dx from minus 1 to 1. Condition is minus 1 to 1. So here taking outside 1 by 2 and 1 dx means x, minus 1 to 1 we get 1 by 2 of 1 minus of minus 1 we get 1 by 2 of 1 plus 1 2. Here 2 cancel, we get the value for CDF is 1. Here CDF is 1. So in the place of this function 0 x less than or equals to minus 1, in place of x minus a by b minus a we substitute the value is what we get CDF in CDF value 1. So in place of this we substitute 1 less than, here a value is minus 1 less than x less than, in b value is 1 and 1 for x greater than or equals to b value is what, 1. So it is the CDF for above problem. Now we have to find out the mean. We know that mean mu equals to formula is a plus b by 2 in the uniform distribution function. So here we know that the AB values, a value is minus 1 and plus b value is 1 by 2. Here minus 1 plus 1 cancel, we get 0. 0 by anything is 0. So here mu value, mean mu equals to value is 0. Here we know that to find out the cumulative density function, we we use the integration. Here we know the PDF value, we have to find the CDF. So using integration, and PDF value is what? 1 by 2 dx. Using this formula we get the cumulative density function is 1 by 2. This cumulative density function value is substituting in this place, because this is the cumulative density function structure. In this place we substituting a value -1, and in this place we get one value, so substituting here, and this is the condition where we be value substituting, we get the CDF value. Here in the uniform distribution function, mean mu equals to a plus b by 2. Substituting a b values we get 0 by 2, that is mean equals to we get 0 value. And variance in uniform distribution function, that is this formula, substituting in the place of a b values we get sigma square equals to 1 by 3. So here we find out the PD probability density function and cumulative density function, mean and variance. Hence we have find out all of this. Hope you love the video guys. Keep supporting me and subscribe the channel and like, share, comment and click the bell icon to be notified every update from my small studies YouTube channel. Thank you guys. Hello guys, welcome to my YouTube channel. Hope you people like the video. Keep supporting me by subscribing the YouTube channel and like, share, comment and click the bell icon to be notified every update from my small studies YouTube channel. Thank you guys.